Hi, this is section 2.4, and today's objective is synthetic division of polynomials. We're going to learn how to divide polynomials using something called synthetic division. But before we do so, I would like to have some quick review about some important vocabulary words that we will be using in this video. In elementary school and middle school, you guys learned how to divide, for example, 63 divided by 4. Now, if you do this on the calculator, you're going to get a decimal, but that's not what we're looking for. You used to divide 63 by 4 using something called long division. And if you would ask yourself, how many times does 4 go into 6, you would say 1, and 1 times 4 is 4. Just a reminder of how you did that long division. You drop down the 3. And how many times does 4 go into 23? 5 times. And 4 times 5 is 20. So you would write the 20 and you would get 3 as a remainder. And this is one of the vocabulary words we want to review together. So you subtract them, you get 3. We call 3 remainder. I want you to keep that in mind. We call 4 divisor because that's what we divided by. We call 15, which is the answer, we call it quotient. That's our answer. And 63 is the dividend. So if I were to write 63 using all those numbers, 63 divided by 4, the result of this division is 15, plus the remainder, which is 3 over the divisor. So in other words, it's 15 and 3/4. So if you do that on the calculator, you're gonna get 15.75. And in mixed numbers, it's 15 and 3/4. And if you want to write it as a statement, and this is what we're going to be doing with polynomial division. So we're going to write the answer as a statement, and we're going to use this format, which is quotient. I'm going to use abbreviation here, plus remainder over divisor. Quotient plus remainder over divisor. So how is it similar to what you guys have done in elementary and middle school? We are still dividing, but we're not dividing numbers. We are dividing polynomials. This is why we call this division of polynomials. Now, are we going to use long division? So here, if you do it in long division, this is what we did with numbers. We can use long division, and actually it's the best way and it works all the time, but it's lengthy and a little bit challenging. So we have another very friendly type of division. We call it synthetic division. So the problem with synthetic division is that it doesn't work all the time, so it has restrictions. And it's restricted to what? It's restricted to two things. Our divisor has to be a linear. So what I'm dividing by has to be a linear. Example, here we are dividing by x plus 1. So that's okay. I cannot divide by x squared plus 1. X squared plus 1 would require a long division. Also, the divisor has to have an a equals to 1. For example, like x minus 7, x plus 3, and so on. Again, if we have a divisor that is not linear, so I'm sorry, for a divisor that is not linear, example, x squared plus 1, or a divisor that has a different than 1, example, 2x plus 3, I must use long division. Now, in our example, the divisor is linear. So I'm going to put that note. Divisor is linear and a equals 1. So with the synthetic division, I can use it. Approved. How do I set the synthetic division? First of all, I should make an L shape. And I should put the coefficients in this L shape. So -5, 3, -2, and right here there's nothing there. That means there is a 1. So in my L shape, I'm going to put 1, I'm going to put -5, I'm going to put 3, I'm going to put -2. Now, what I'm going to do next is not a must, but it's highly recommended. So on top of each coefficient, I want to put where it came from. So the 1 was next to the x cubed, the -5 was next to x squared, the 3 was next to x, and the -2 had nothing next to it. This is why we call it a constant. And now how do we proceed? We drop the first coefficient down. I need to know what I'm dividing by. So I'm going to look at the divisor and I'm going to equal it to 0 because I'm looking for the 0 of this polynomial, which is -1. And I'm going to place that -1 on the outside. So drop the first coefficient, take your divisor, equal it to 0, and get what you're dividing by. Now you proceed. You multiply -1 and 1, and the answer you put it next in the next space. Then you add those two coefficients. You don't subtract, you add. This is a very common misconception because we just saw that in long division, but we're not doing long division. So -5 added to -1, that will be a -6. And I'm going to repeat the process over and over. -1 times -6 is a +6. And I'm going to add those numbers or those coefficients. They're going to add up to 9. -1 times 9 is -9. And I'm going to add those. Now I need to label these because we said we're dividing polynomials. When we divide polynomials, we're not going to get a numerical answer like 5 and 3/4 or 15 and 3/4, 15 plus a 3/4. No, we're going to have a polynomial. And here, if you notice, we are dividing a cubic by a linear. When we divide the cubic by a linear, when we divide, we subtract exponents, we're going to end up with a quadratic, which means the cube has to be reduced by 1. X squared, also take the exponent 1 down. This now has nothing next to it, is going to be the constant. And -11 will be what we called remainder. So if we want to write our answer in the statement in the fraction form, we're going to need the quotient. So this division equals the quotient, which is x squared minus 6x plus 9, plus the remainder over the divisor. And this will be our polynomial result. This is what will result from dividing that big cubic polynomial by x plus 1.